Hello everyone, my name is Tanway. I'm 10 years old. Today I will share about what if we dug a hole through the earth. Imagine sitting on a peacefully built drill. Drill is the thing that you use to dug up the earth, ready to bore through the earth from one side to the other. It seemed like a thrilling idea, but just dive into the tunnel, free fall at incredible speed and shoot out from the other side of the earth. It's like a human bullet, but as cool as it sounds, this journey is a recipe for disasters. You see, Earth isn't just drill and rock, it's a layered structure, each layer more intense than the last. So the first challenge will be facing the drilling through the crust. The outermost layer, about 60 miles thick, this is where we live. And even though it sounds manageable, digging deep is no easy task. The deepest hole ever drilled here is the Kola Super Deep borehole in Russia, which only reached 7.6 miles, and that's barely a scratch on the surface. Like Earth have it's like the inner core, the outer core, and the surface. So the surface was very long, so it just like a scratch on the surface, like it's just a little bit. That's all, and that's barely a scratch on the surface. Where if you go deeper and you face rocketing pressures 4,000 times more than sea level and temperature hot enough to melt steel, like melt metal. But let's keep going through the crust and enter the main mantle of 40 miles thick layer of molten rock and shifting tectonic plates. Temperatures here soar to over 2,570 degrees Celsius and Fahrenheit. That's really hot. It's hotter than the volcano. A volcano can melt a lot of things, but here is even hotter than a volcano. And a regular drill would melt instantly because it can't hold that hot. So to survive this part of the journey, you need a drill made of incredibly tough materials like titanium. So to cross this 2,570 degrees Fahrenheit, you need a drill that was really hard like titanium. So next comes the outer core, a swirling sea of molten iron and nickel, about 1,800 miles below the surface. Temperature here range between 7,200 degrees Fahrenheit and 9,000 Fahrenheit. That's degrees Fahrenheit. That's even harder. So basically, if you get into that, you will melt. Other things will melt instantly. It's like an ocean of lava. I think it's harder than lava. And because it's liquid metal digging through, it won't be like trying to carve a path through molten soup. Still, for sake of imagination, let's say you keep going, and it doesn't matter your drill. Let's just going. If you somehow make it past the outer cone, here the pressures if you manage to get over past the outer core, you will reach the inner core. Here the pressure is over 350 million times what we experience on the surface. That's really hot. But it's not as hot as the sun. But what we're experiencing on the surface, even though temperature remains scorching, the immense pressure keeps the iron and nickel solid. At this point, your drill would be under unimaginable stress, likely destroyed long before reaching the other side. But let's suppose you manage to leave the inner core as you pass Earth's center. Gravity will start pulling you back where you originally came from. Like when you, and the harder you go, the stronger the gravity will pull you. So you will easily like get up. So that's wow. That what if we dig a hole through Earth? We could just, if we have a drill, we could just dig through the Earth's surface. But in the inner core and the outer core and inner core, it might be impossible. But if you might find some very strong materials to get through that, maybe it could. And you have to take the gravity if you go past the middle, like it has the center here, and if you pass the center, the gravity will pull you back. And the farther you go, the stronger the gravity pull. So that's it. And today, thank you for listening. Goodbye, see you again. Bye bye.